We're testing a Marconi 6910, serial number 1284. There's the calibration table on here. And the details on the sensor itself. We'll go back. We're using a 6950 for testing, and the first thing to do is to try and calibrate it to 0. Now I'm in a very RF noisy environment here. I need to turn, we need to turn the response right up. We're going to adjust to 0. The calibration is set to 100%. There we go. Very, very sensitive adjustment here. Very tricky to get that to 0. Let's do that. There we go. Oh, that's too much. So the 0 adjustment is done with the dial sitting on. There we go, that's close enough for our little test here. All we want to establish is that the sensor is functioning as it should. Here we go, that's it here. There's this, oh no, it's drifting. Very, very tricky, particularly with that response time delay that's in it. There we go. Okay, we'll leave it at sitting at that. No, it's still drifting down a little bit. Still need to get everything where are we? Just need to put the phone down for a sec so I can use both hands. So we finally got that sitting close enough to 0, and this is on the most sensitive range, which is the -25 dB range on this instrument. So that's the 0 calibration for the sensor. Now we'll go to the gain calibration. I'll put the phone down and connect the sensor. We've now got the sensor connected to the internal source power reference, and we've got it switched on. There is a gain adjustment here, which I just need to put up ever so slightly. There we go, that's close enough for government work. The calibration is set to 100 as it should be on the 50 meg power reference, and the range is set to 0 dB. So we've now got the instrument calibrated. I'll now get the frequency generator out and we'll hook that up. We're using the Marconi 203i frequency generator set to 50 megahertz and putting out 0 dBm with no modulation. The power sensor is connected to the output, and we go back to the meter here and we can see we can see the meter being up at 0 dBm, and now I'm winding the output back, and I'll just wind the output back here to minus 5 dBm. It's about minus 5 dBm. Have a look. There we go, that's sitting at about minus 5 dBm, and I have a look here, that's minus 5 dBm. Let's just adjust it to a different number and go to minus 3 dBm. Here we go, minus 3 dBm. You can see that's showing minus 3 dBm here. So there we go. We can see that's working. Now if I adjust that to minus 5 dBm and then change the range here to the minus 5 dBm range, we can see that's now sitting at 0. So that's 0 here is minus 5 dBm, and let's go back here and adjust that to minus 10 dBm. There we go, minus 10 dBm. And we can now see that's sitting at minus 5 dBm again. And so we've got minus 5 here at 0, minus 5, so minus 10 dBm. So that's how that works. And if we go to the minus 10 dBm range, that'll come up and it'll make its way to the 0 range. I'll see how that response, yeah, I've got that response still slowed down a bit. And we adjust that to minus 15 dBm. There we go, minus 15 dBm. And we go back, and that's showing us our minus 5 dBm again, reading by the sensor. So minus 10, minus 5 gives us minus 15 dBm. So that's how I'm testing my sensors, and I think this particular sensor is working okay. It's doing all the things that it should be. The calibration on this instrument is a bit of is probably the most tricky part. I'd say it's not quite, if I was to put it back to 0 or put it back to full on this range, I probably have to recalibrate again. The 0 and the gain here, you need to go through them a couple of times before everything is right, and have it all warmed up. And I've started this cold, so all the equipment is still warming up. Anyway, the sensor, as far as I can see, is working okay.